Now, one thing I didn't mention in the other video is just the tangent is always the opposite over the adjacent. The sine is always the opposite over the hypotenuse, and the cosine is always the adjacent side over the hypotenuse. And again, this is only for right triangles. So I just want to briefly mention that before we get into some more examples, and especially using angle measures and figuring out angle measures. So, for example, let's say I'm sitting there and I'm going, well, if you're telling me that the angle, we did sine of 45 degrees, right? And it was the square root of 2 over 2. Well, that means that if this angle right here was 45 degrees, and I'm just going to mark it, then that means that this opposite over the hypotenuse is the square root of 2 over 2. That's going to be the opposite over the hypotenuse sine of 45 degrees. So the sine of 45 degrees, so we actually know the angle measure, the ratio for that is going to be the square root of 2 over 2. So that means that if I know the angle measure and I don't know one of the sides, I can use that ratio to solve for the missing side. So for example, if I know that, one of the sides, I'm going to make this up, sine of 45, if we know the angle measure is 45 degrees, and I know it's equal to square root of 2 over 2, that's what the ratio needs to condense down to. And let's say that I gave you that the denominator, that this side opposite of it over here was, instead of 3, let's say it was, well, let's leave it 3, but let's say the hypotenuse was unknown. I don't know how big the hypotenuse is. I wish I could figure it out. And we don't know the adjacent side either. We're going to go with that for now. But I know how big the tree is. So I want to know, hey, how long would it be for me to create a zip line from the top of the tree to the ground at a 45-degree angle? Well, what I could do is I could use the fact that I know that the ratio should be square root of 2 over 2. So if I know it's 3, then that means 3 over the hypotenuse, or x, so the opposite over the hypotenuse, because again, the hypotenuse is unknown in this example, is equal to the square root of 2 over 2. And now you can see where that geometric mean and all those things that we learned from chapter 7 are coming back. So we want to make the denominators the same. I would make this x over x, and I'll make this 2 over 2. So now the denominators are both 2x, so that means that we have square root of 2 times x is equal to 6. So we would divide by the square root of 2, and for that I would pull out a calculator for right now, all right? And I would do the 6 divided by the square root of 2. And that would tell me the hypotenuse is 4.24, and I forgot to say if it was meters. Let's use meters there. So that would mean that the hypotenuse in this example, where if the opposite side is 3 and the angle here is 45, the hypotenuse has to be 4.24. Again, if we're talking about meters, there you go. And maybe that makes sense, right? 3-meter tree, 10-foot tree, not a huge tree, right? But maybe we're not ziplining from it either. It's not big enough to zipline, but that's how you can use these ratios to actually solve for unknown side lengths. And likewise, if we know all the side lengths, we can use it to solve for the angle that we're let's say we don't know this angle. We can use the inverse sine. So let's say I know the ratio, okay? So I know the sine of 45 is equal to square root of 2 over 2. But let's say I didn't give you the angle measure. Let's just say I said, hey, the opposite side is square root of 2, the hypotenuse is 2. You would say, well, then I know it's a 45-degree angle. It has to be, because no other sine angle measurement is going to have a ratio of the square root of 2 over 2. So let's use another example. Let's say, and I'm going to clean this up a little bit here. Let's say I'm like, hey, I don't know the angle measure, but I know, I know from before that this tree right here is, 20 feet tall, and I know that I measured the shadow is 15 feet. What angle must the sun be at for that to be true? For the shadow to be 15 feet, how high up in the sky is the sun, or what angle are we at for the sun? So we can do that by using the inverse sine. So saying, hey, I know the ratio, sine -1. But it's not -1, it's inverse, okay? So you have to understand in math, when you see a -1 exponent, it means the inverse sign. So now we can say, okay, well, if we take that ratio of the opposite side over the hypotenuse, oops, I did opposite and adjacent. So instead of sine, I should be using tangent. Because I want to know this angle, so I have the opposite side and I have the adjacent side. So the tan, -1, so I want to know the angle measure, of 20 over 15 is going to be some angle measure degree here. So let's return back here. So I'm going to go ahead and do inverse tangent of, what was it, 20 over 15. And that is going to tell me that, hey, that angle measure is 53 degrees. So the sun is at an angle of 53 degrees when the tree is at a ratio where it's taller than the shadow is long. And it's 20 to 15. And you can see how exact the calculator gets here. I mean, the calculator gets, 53.13 going on forever. So that's an irrational number. How's the calculator do that? There's an algorithm. And again, I mentioned this in another video. If you're interested, see me, there is a really good Wikipedia page that explains it. And it goes into computer science. It goes into, all the math behind it. And you think about it, we've been using these calculators for probably, at this point, 50 years. So it's pretty incredible that they were able to create that algorithm and do it in, essentially something something that's handheld. Pretty crazy. So we said that's about 53 degrees. And I say about because none of these are going to be exact. It's irrational. And that's how you do these problems. That's how you solve for these unknown lengths. And you're going to, I'm going to hand out a worksheet too in class where you can do this with me a little bit. But if we just look at some more examples, I'll do that in the next video. So this video is not as long. And let's end it there. Oh, one thing I forgot to mention. Before I began all of these videos, I changed the mode from radian to degree because I was talking about degrees. Radians are something else that we'll talk about when we do the unit circle. But right now, all you need to know is you want your calculator, if you're using calculator at your desk, to be in degree mode because that's what we're working with here is degrees, not radians.